So, last class I have discussed about the load carrying capacity of pile based on SCPT data. So, how we can calculate the load carrying capacity of pile using the SCPT data. Today I will discuss how we can calculate the load carrying capacity of pile based on the SPT data. So, this is the second method or using the n value, second penetration correlation, penetration data correlation, that is the using the n value. N value is the SPT value. So, this is the QPU I can determine by using these expression, where L is the length of the pile, D is the diameter of the pile, and remember that this value cannot be greater than 400 N. It is in kilonewton per meter square. N is the SPT value without overburden correction. Okay, remember that. So, this is the way we can determine. And another one, that for the friction resistance we can use, this is the N average 2 for the driven pile or the displacement pile, and for the H section pile Fs is the N average, and average field value is the along the pile. So, that means when I calculate the friction one, then this total length average N value is the average. Okay. So, that is called the N average along the length of the pile for friction calculation. Again, this value cannot be greater than 100 kilonewton per meter square. Also, this cannot be greater than 50 kilonewton per meter square. Okay. And the tip resistance, generally the where the pile is rested, that portion N value is considered. Okay. So, this is the expression for the N value part, and similarly IS code also given similar type of expression for load carrying capacity of the pile. This is the tip resistance, this is the friction resistance. The similar value N average here is the N bar is the N average. So, this is the along the pile shaft. Okay. And this A is the AP is the cross section area of the pile tip in meter square, N is the average value in pile tip, and this is this area is in meter square. So, ultimately you will get kilonewton, and this is the area you are multiplying. So, ultimately the unit will be kilonewton. This is for the cohesionless soil, and this is for the plastic silt or very fine sand. This is also kilonewton. So, this way you can determine the average value, the way I have discussed about the SCPT data case. So, you can use that method. So, this way we can determine the load carrying capacity of the pile. So, and this way I have discussed about the 4 methods, that the static equations, your pile load test, then based on dynamic equation, and then based on the penetration correlations or the penetration value, the SCPT and the SPT values. And all the equations or the correlations are given for driven pile. Now, if the pile is bored or the cast in situ, then the tip resistance is 1/3 of the pile resistance given by the board driven pile. Okay. And frictional resistance is half of the friction resistance that you will get for driven pile. So, what you do, you calculate the QPU and Fs based on the equations given for driven piles. Then for tip resistance you divide it by 3 for the board and cast in situ pile, and for the friction resistance you divide it by 2 for the board and cast in situ pile. And for the driven and cast in situ pile in sand, so that QPU and Fs will be taken same as the driven pile if it is driven cast in situ case pile, because I mentioned that your concrete pile can be precast and cast in situ. Cast in situ can be 2 types, one is the driven, another is the board, and in the driven cast in situ can be two types, one is cased, another is uncased. Okay. So, for the driven cast in situ cased pile, the QPU and Fs will be same as the driven pile, but for uncased pile the Fs will be equal to the Fs of driven pile if the proper compaction of the concrete is done, okay, and if it is will be equal to the board cast in situ pile if the proper compaction of concrete is not done. If the proper compaction of concrete is not done, then the Fs will be equal to the Fs of board pile, okay, and if compaction is done, then Fs will be equal to the Fs of driven pile, okay. So, if it is uncased, and cased QPU and Fs both are equal to the driven pile. So, these are the information. So, now the next one that I will discuss is the group action of pile. Till now I have discussed the pile load carrying capacity based on a single pile, but pile will be used as a group. So, how I will calculate the group capacity of a pile, and then how I will calculate the efficiency of a pile group. So, that I will discuss in this section. So, this is the piles in group. So, this can be a 2 pile group, 3 pile group, 4 pile, 5 piles, 6 piles, this is 7 piles group. So, you have more number of piles in a group, you have then more than 7 also. So, but the distance between 2 piles, center to center distance between 2 piles is the spacing between 2 piles. So, depending upon the spacing, your efficiency of pile groups will change. Okay. So, now how we will calculate the efficiency of a pile group, that the efficiency of a pile group is the group load carrying capacity of pile divided by number of piles into the single load carrying capacity of pile. Okay. So, this is the pile group, we can calculate group efficiency like this. Now, if the spacing is small, then what will happen? The influence zone of each single pile will overlap each other. So, your group load carrying capacity will reduce. So, the efficiency of the group pile will reduce. Now, if the pile is driven in a loose to medium sand, then what will happen? Due to the pile driven, the soil will be compacted. It is a loose sand. So, soil will be compacted. So, your strength of the soil will increase. So, your load carrying capacity of the pile will increase. So, if the single pile, if you drive it, so there is a group action. So, because if you have a say group pile, so that means when you are driving the piles into the soil, so this portion of the pile will be compacted, will become dense. So, you have a more pile load carrying capacity in group compared to the single. So, in that case your group efficiency will increase, but we never use the group efficiency more than 1 during the design. We consider it is equal to 100%, but actually it is more than 100% if it is driven pile in the loose sand. But if your length of the pile increases, spacing between the pile increases, then what will happen? Your influence zones will not overlap. So, that each pile will be a single pile. So, your pile load carrying capacity will be equal to the number of piles into the single pile load carrying capacity, because if there is no influence influence zone is overlap, then every pile will give you the equal amount of load carrying capacity, okay, in the soil, because there is no overlap. So, now if you multiply it with the n value, that will give you the load carrying capacity of a group. So, if the spacing is small, then your efficiency will be less than 1. If the spacing is more, efficiency will be 1. If it is driven pile into the loose soil, efficiency will be greater than 1, but during design we generally consider efficiency is 1. We never consider the efficiency is greater than 1 during the design. Now, the another way also we can determine the efficiency of a pile group, that this is based on the number of rows and the any piles in the number of rows. So, this is the pile number of rows, Okay. So, here m is the number of rows in a pile. So, number of rows means 4. So, here m value will be 4 and then per column in a row. So, per column in a row is also 4. So, your n value is equal to 3. Number of piles in a number of rows is 4 and number of pile in a row is also 4. So, it will be m is equal to 4. Sorry, this will be n will be also 4. Okay. So, number of pile in a row is 4, number of row is also 4. D is the diameter of the pile, S is the spacing between pile. So, you put this theta value and this way also you can calculate the group efficiency of a pile group. So, generally that minimum pile spacing is recommendation is like this. If your pile length is greater than 12 meter, then friction pile, that is in sand, it is 3D, friction piles in clay is 4D and point bearing pile is 3D. I have mentioned what is friction pile, that is most of the majority of the contribution due to the friction, and the bearing pile majority of contribution due to the bearing. And if it is 12 to 25, this is the recommendation, more than 24, this is the recommendation. IS code has also given the recommendation, if it is bearing pile, the minimum spacing, these are the all minimum spacing. Okay. This is also minimum spacing. Is 2D, for friction pile is 3D, and loose sand or field deposit it is also 2D. So, next one, that how I will calculate the load carrying capacity of a pile group in clay. Okay. So, when we are calculating the pile load carrying capacity of a pile group in clay, we consider is at a as a block failure. Okay. For example, if you have a pile, so suppose this is your pile group, so this is the outer periphery of this pile group. So, total pile will fail in a block like this. Okay. So, the in such case our load carrying capacity is same as Cu base Nc into Ab plus your alpha Cu your As. Okay. So, that means here Nc is again equal to 1, Ab will be here, Ab will be area of this block. Okay. So, if this is the B and this is the L, then LC will be B into L will be the AB. Okay. And here alpha value will be equal to 1. Why? Because it is settling as a block and in between that this is the soil. So, most of the interaction when this block is deforming or deflecting, then the friction is between soil and soil, because this portion is soil, this portion is soil, this is soil, this is soil. So, it is between soil and soil. So, that is why adhesion factor is 1. So, we will get alpha equal to 1, Cu is the Arnden coefficient and As will be here, As will be 2 into B plus L into the length. L dash is the length of the pile. Okay. So, here or you can see this is L dash, then this will be the L, L is the length of the pile. Okay. So, this way we can determine AB and the AS. And the next one, this is a block failure when spacing is less than 2 to 3 times of the diameter of a pile, then there will be block failure, then there will be a group failure or the block failure if the spacing is less. Now, if the spacing is more, then there will be individual pile failure, and then you calculate the load carrying capacity of a single pile, then multiply it with the number of pile, you will get the load carrying capacity of a group pile if your spacing is more. Okay. So, that means if the spacing is less within 2 to 3 times of diameter of the pile, there will be a group failure. So, we have to consider a block failure, and if the spacing is more, then you have to consider the single pile failure. Okay. Now, what I will do? Now, I will solve one particular problem. So, where I am taking determine the spacing of a group of 16 pile with diameter 300 millimeters such that the efficiency of the pile group is 1. Okay. Piles were constructed in uniform clay soil with unconfined compressive strength of 550 kPa. Okay. So, now if I solve this problem, then so I can solve this problem that this is a 16 pile. Okay. So, 16 pile is like this 1, 2, 3, 4, 5, 6, 7, 8, 12, 16, okay, 4 cross 4. So, spacing between each pile is, we have to calculate, and say suppose that is S, and diameter of each pile is 300 millimeter. So, that this outer dimension of this outer zone will be that dimension of the width direction B will be 1, 2, 3, 3S plus D. Okay. And for the L, if this is the L dash and this is the B, then L dash will be again 3S plus D. Okay. Now, our QU is given 50 kilonewton per meter square. So, as I mentioned, Cu will be 50 divided by 2, 25 kilonewton per meter square. Okay. So, now our group efficiency will be 1, okay, and the group efficiency is QU in group divided by n number of pile into QU single. Okay. So, first I will consider the block failure. So, in the block failure QU or QU in G, that is the group, will be equal to CU NC into AB plus alpha is 1. So, CU AS. Okay. So, we can write that our QUNC value is NCQ and AB, and one condition is given that you neglect the bearing resistance or tip resistance of the pile. So, we are neglecting the tip resistance of the pile. So, that portion we are neglecting, okay, that we are consider as a 0. We will consider only the frictional part. So, Cu into AS for the group. Okay. So, that means here that condition was given in the problem. So, this is the condition we are considering only the frictional resistance. The reason is that it is the floating pile, it is not resting on a hard strata. So, the majority of the contribution will be from friction. So, that is why we are neglecting the tip resistance, that is the logic. So, that means the Cu into AS will be 2 into B plus L dash into L. Okay. So, that is the group perimeter into the length. So, I can write that your Cu value is 25 into 2 into S 3S plus D plus 3S plus D into L. L is the length of the pile. Okay. So, I can write that your this will be the 25 into, if I take 2 into 2. So, this will be 3S plus D, because 3S plus D. So, another 2 into the L. Okay. So, this will be your equal to 100 into 3 into S plus 300 millimeter into L. Okay. So, S is in millimeter here, because we are taking D is in millimeter. So, this is for the block failure. Now, for single pile failure, that your single pile capacity Q U S single, again we are neglecting the tip resistance. So, it will be Cu into S into alpha, because now for the single pile capacity it is not, alpha is not equal to 1, alpha is equal to some value. Now, from the chart we will get alpha is from 9.95. We have given the figure of photographs of the alpha, or the chart of the alpha, or the graph of the alpha corresponding to Cu. So, Cu value is 25 kilonewton per meter square. So, alpha you will get 0.95. So, here again this I can write that 0.95, Cu value is 25, S is pi into D into L. Okay. So, or I can write 0.95 into 25 into pi into 300 into L. Okay. So, now I have mentioned that our group efficiency is 1. So, this is Ug and N, or the number of pile, that is N into Us. So, Ug I can write that is equal to, the Ug value is this one, 100 into 3S plus 300 into L. So, 100 into 3S plus 300 into L divided by N is 16, and then single value is 0.95 into 25 pi 300 L. So, 0.95 into 25 into pi into 300 into L. Okay. So, finally, I will get that 100 into 3S plus, because this value is equal to 1, because in the case of 1. So, I mean we have checked it, if the spacing that I will get, if I provide the spacing less than that, then there will be a group failure. If I provide greater than that, there will be a single pile failure, but we are taking the optimum spacing, so that our efficiency is 1. So, S plus 300 into L, that will be equal to 16 into 0.95 into 25 into pi into 300 into L. So, this L will cancel out, and then if I simplify these things or solve this one, then we will get my S will come 1094 millimeter. Okay. And so, the spacing, if I provide that spacing is 1094 millimeter, then the efficiency will be exactly 1 or 100%. And as per IS code, the minimum spacing S minimum for clay or friction or point bearing is we get 2 point, this for the IS code is 2.5 D and or 3 D. So, this is the minimum spacing. Here it is coming out to be 3.65 D. So, it is okay as per the requirement of the IS code, the 2.5 or 2. So, because 3D is the maximum requirement for minimum spacing. So, it is giving 3.65. So, it is safe. So, that the spacing that we will get is 1094, and that will give you the spacing that should be used to get the 100% efficiency. So, next one, the settlement calculation of pile group. Okay. It is also very important. So, till we are talking about the load carrying capacity of the pile group. Now, this is a how we will calculate the settlement of a pile group. Okay. So, there are 3 possible conditions I have selected. That one is your pile is installed and it is in the clay, remember that it is in the clay. So, your pile, it is in the clay, pile is installed in a uniform clay. Then what is that? That it is assumed there is a raft you are placing on the pile. So, the dimension of this raft will be this one, okay, from this edge to this edge, this is the B. So, you place this raft here, which is 2/3 of the length of the pile. So, you place this raft here, then the calculation is exactly similar to the raft foundation calculation. This is the immediate settlement equation, but you have to place the raft here, then distribute the load 2:1, and then from here up to the twice of this width, you have to consider the influence zone for settlement calculation. But remember that this raft is placed at 2/3 of length if it is a uniform clay. Okay. And then the rest of the calculation is exactly same as the raft foundation calculation. Okay. So, these the terms are same as we used for the raft foundation calculation. This is for the immediate settlement. Then similarly, this is for the consolidation settlement, and these terms are same exactly that we used for our shallow foundation calculation. But remember that raft you have to place at 2/3 from the top of the pile cap, and then influence zone will be twice of the width of the pile from that 2/3 of the length. Okay. And then if suppose this upper layer is very weak soil, but lower layer is very strong soil, but previous one is the homogeneous clay, but here the upper layer is very soft, but the lower layer is very strong, okay, or stiff layer or hard layer. Then you will place the raft as twice the length, 2/3 of the length of the lower layer. Okay. So, this is the L1, 2/3 of 2/3 of L1 you have to consider. Okay, 2/3 of L1. Remember that this condition. The third, after that it is same as 2:1 distribution. From here it will go up to the twice of the influence zone. And then if this pile is rested on a very strong layer, because this is the very strong layer, the soil is very strong and pile is rested on the strong layer, then from that base you have to place the, you have to distribute the load, and at that base you have to place the raft. Okay. So, and then for the, these are the settlement for the clay, and similar to the settlement for the pile group in sand also we can calculate that this is the settlement of a group pile and the settlement of an individual pile, and this is the expression which is proposed by Skempton, and this is the expression which is proposed by the Mayerhof. Here B is the width of the pile in group, that is in meter. So, here B is the width of the pile in group, means suppose we have a pile group like this, then B will be this one, width of the pile group. Okay. This will be the B, and B is in meter, remember that, and then we will get the settlement from this equation. Now, the question is how I will get the settlement for the individual pile. So, the individual pile settlement I can get from the pile load test. So, we can do the pile load test. So, from there we can get the allowable load carrying capacity of the pile. Now, from that load carrying capacity correspond what will be the corresponding settlement that I will get from the pile load test data or the curve, that settlement we can use here, and we can get the load settlement of a pile group. Okay. So, this is the equation, we can get the settlement from here. The similar way, if I use the same pile load test data that we use in the previous single pile calculation, and if I use that data for the pile load test calculation of or settlement calculation of a group pile, then in the previous problem in the single pile load test that we have used that our Q allowable was coming out to be 153 kilonewton per meter square, or sorry, this is the kilonewton, 153 kilonewton. So, that is the Q allowable based on the IS code. If you look at this problem that I solved for the single pile during single pile load test, when I discussed the single pile load test, that time I solved this problem. Okay. So, this is the load versus settlement curve, and based on the IS code recommendation we got that Q allowable was 153 kilonewton. So, this is the load in kilonewton, this is the settlement, okay, in millimeter. So, initially we applied two clauses, and then we got that Q allowable was 153 kilonewton. One clause was 2/3 of the load at which settlement attains 12 millimeter, and second clause was 50% of the load at which settlement attains the 10% of the pile diameter. So, we apply these two clauses and we got this 153 kilonewton is the allowable load. Now, corresponding to 153, so this is your 110, 140, 153. So, 153 your settlement is coming out to be 8 millimeter, that is for single pile. Okay. So, because this was the single pile load test data, so I can write that my SI is 8 millimeter. Now, if you have a 9 pile group, with spacing 900 millimeter and diameter of pile is 300 millimeter, then what is the SG, settlement of the pile group in sand. Okay. So, the B value is, if we have a 9 pile group, so this is the 9 pile group and the spacing is 900 millimeter and diameter is 300 millimeter. So, B value will be 2 i's into 900 plus 300. Okay. So, this will be 2100 or 2.1 meter, 2100 millimeter or 2.1 meter. So, if I use the Skempton equation, that Sg by Si, that is equal to your 4 into 2.1 plus 2.7 divided by 2.1 plus 3.6. Okay. So, we will get that is equal to 3.8. You are using the Skempton equation. So, from here Sg will be Si into 3.8. So, that will be equal to 8 into 3.8, that is 30.3 millimeter. So, this way, if we have the pile load test data, from there also we can calculate what is the settlement of a pile group, okay, by using this Skempton equation or the other available equations. Or directly, if you have a pile load test data for pile group, from there directly you can get this what will be the settlement corresponding to allowable load carrying capacity of the pile. So, with this I am finishing today's class. In the next class, I will design a pile foundation in clay. In that case, I will check both bearing as well as the settlement, and then we will decide what will be the dimension of the pile, I mean spacing, diameter and the length of the pile. And then next I will discuss the last topic of this pile foundation, that is the negative skin friction. Thank you.